Hello everyone, you are listening to Komalta and welcome to my channel. Guys, in this video, I'm gonna talk about this very important topic from examination point of view, which is superposition principle, and you'll see a lot of examples, lot of questions from this topic in the exam. Fine, guys. I'm going to make it very easy as possible. I'm going to explain this in very easy language so that you can understand it, right? So without delaying, I guess we should start, right? So let's start, guys. First, I'm going to take this example, which is this one, this radial representation of hydrogen atom. Fine, guys. So guys, this hydrogen atom representation we are going to see in the later lectures, guys. This is hydrogen atom. Fine, and this is the radial representation of 2s orbital and 2p orbital. I'm writing which is 2p orbital and which is 2s orbital. Guys, don't get confused. I'll explain it later on when I'll be explaining hydrogen atom. Fine, but for just now, I want to explain superposition principle. I can only explain superposition principle with this example. Fine. Suppose, guys, the curve of 2s orbital is this. The radial, this one, r square, r20 square for this 2s orbital is this. Can you see, guys? Yeah. So this is the curve which I'm drawing. So I hope you can see it. Yeah. And the another dotted curve that belongs to 2p orbital of hydrogen atom. Suppose a position is there. Suppose if I want to find some position and I want to say that this position belongs to 2s or 2p. Fine. Suppose a particle is there, and if I want to say, because can you see this region? This region is overlapping region, because this is 2p also and 2s also. But if some point is lying over it, so I can't say that whether it is belonging to 2s only or 2p only. Fine. For that, guys, superposition principle comes into play. That comes for rescue. Fine. So for defining that this state belongs to whether to 2s or 2p. So guys, we are going to take, so this is called superposition principle, that positions are overlapping. So here can you see positions are overlapping. We are not able to say whether it is of 2s or 2p. Fine. For that, we are going to use superposition principle. That is the underlying principle of superposition principle, and that is the easiest language I could use to explain it, right? For what we are going to do, guys, suppose there is some particle and I'm going to define that state by this wave function, overall wave function. This is the wave function corresponding to this state. Clear, guys? So what I'll take now to define this state, because I don't know whether it is belonging to 2s or 2p. Fine. So what I'll do, because can you see this point also has some contribution from 2s and also from 2p. So I'll take the linear combination of both orbitals, that this 2s and 2p. Clear? So guys, I'll take wave function corresponding to 2s also, and I'll take wave function corresponding to 2p also, and I'll add them. Wave function defines state, guys. Wave function is representing a state corresponding to 2s orbital. Fine. State corresponding to 2s orbital. Suppose a particle is there in 2s orbital, that will be defined by this wave function. Clear? And if suppose particle is in 2p, that will be defined by this wave function. Clear? Because in quantum mechanics, we always go by wave function. If I want to define something, I will explain it by wave function. So if I want to say something about this particle or this something microscopic particle, and if it is belonging to 2s, I will write wave function, which is denoted by psi and which is corresponding to 2s, and I'll take all possible possibilities. So now here it is also lying between 2p. Fine. Here it is also lying between 2p. So I will also write wave function corresponding to 2p, which I have already wrote. Clear? So now I will also write some coefficients also here, guys. This is C1 and this is C2. Fine. So you will be thinking that what is C1 and what is C2. So guys, this C1 simply defines the probability of finding the particle in 2s orbital, because you know that we can't explain the exact location or exact position of quantum particle. You must be knowing that we can never define, just for now, because like any discovery can be possible later on, but for now we can't describe the exact position position of any particle. So we always talk about probability of finding the particle. You must have seen many questions where we talk about that what is the probability of finding the particle. We never say that what is the location of particle, fine, because that we can't find. So the probability of finding the particle in this two-way state, that will be defined by C1. C1 is, you can also see here, the coefficient attached with the individual state. That means this coefficient attached with this individual state describe the possibility of finding the quantum mechanical particle in concerned state. That means it is defining the possibility of finding that particle in two-way state. Similarly for C2, this coefficient is defining the possibility of finding the quantum mechanical particle in this orbital. This is defining the probability in 2s orbital. Fine, this is defining probability in 2p orbital. And guys, we always go by like this. Suppose if there are three wave function, suppose there are three curves like this, someone is like this, and someone is like this. Fine, if someone is saying that what is the position here, fine, what is the wave function corresponding to this state, so we will take all possible combination, all three state, fine, then we'll take all three state, clear. So here it was two states, so I took linear combination of two state. It can be of three state, four state, depending on how many graphs are overlapping. Clear guys, I hope that is clear to you. Simply we'll just say that this is just overlapping of positions, fine, that is overlapping of positions. Simply that is the, if I say, that is the moral of this principle, fine. So let's dive into another slide without delaying. So there is one condition also guys, there is one condition which I want to tell you that so that condition is important, so let me tell you that. Clear. So guys, one thing, that if you want to write this wave function, like that, suppose now I have forgot about this 2s and 2p, now I take random state, that this phi1 and phi2, fine, these are random states, and if I'm writing the overall wave function, so this c1 is the coefficient of finding, that coefficient, that means probability of finding the particle in this phi1 state. Guys, this can be anything, fine, I'm just taking one random example, and this c2 means define the probability of finding the particle in this phi2 state, clear. But for this, like if it suppose, you can read over here, let us consider psi is the superposition function that is written by taking the linear combination of two orthonormal state phi1 and phi2. So guys, this is possible when we consider that this phi1 and phi2, this is the condition for this, that we can write it like this, when phi1 and phi2 are orthonormal. So you must be confused that what is orthonormal. So I'll be telling you the difference guys, what is the difference between this orthogonal and this normalized thing, and what is orthonormal. So can you see guys, this orthonormal, it's self-explanatory. It is can you see it is orthogonal also? Can I write it like this? Orthogonal plus normalized. Orthogonal plus normalized, fine. So what is the meaning of orthogonal? Suppose guys, if someone is saying that phi1 and phi2 are orthogonal, if someone is saying that phi1 and phi2 are two states and they are orthogonal, so that means their integration like this, phi1 phi2 d tau will be 0, their integration will be 0. If someone is saying that phi1 and phi2 they are normalized, if someone is saying they are normalized, then what you will do, that there this one, that individual phi1 d tau is equal to 1, that is integration with itself, that would be 1, and integration of with itself of another one, that would be also 1. If someone is saying that it is orthonormal, if someone is saying that is orthonormal, so that means all these conditions will be satisfied. That means for orthogonal also it will be satisfied, and for this normalized also it will be satisfied. Can you see, I have written the same thing, that it is orthogonal also and it is normalized also. Orthogonal means this phi1 phi2 d tau is 0, fine, the integration is 0, and this normalized means that integration with itself, like the phi1 and phi1 d tau, that would be 0. 0, you can see in this box that phi 1 and phi 1 d tau is 0, and another one is the another state that phi 2 d tau is 0. You can see phi 1 d tau is 1. I'm so sorry, I take my words back, that phi 2 d tau is 1. Clear? That normalized, these are normalized, fine, these are normalized, and this is orthogonal, and combinedly, like if both conditions are there, orthogonal and normalized, we will call it orthonormal. That means they are orthonormal. I can say that they are orthonormal. Fine. So guys, I want to give you one warning for question. Whenever you are attempting question for this superposition principle, always guys, you have to take care of one thing. You will always see whether this function is normalized or not. Whatever is asked in the question, anything is asked in the question, you will only see that whether the function is normalized or not. So right now I'm going to tell you how you will check whether the function is normalized or not. So let's go ahead. Fine guys, so let's say guys, if psi is normalized, so that means this is the condition that this psi should be normalized. Fine, this is the condition that this psi should be normalized. Clear? So this is different thing, and it's this psi should be normalized. For it to be normalized, you know that every function should be normalized. Clear? So this psi should also be normalized. Clear? Because you can see in particle in 1D works also, we see that they are normalized. Fine. So for this one, this also be normalized, guys. This can be normalized only when you should be knowing the this one, the condition of normalized, that psi star psi d tau should be equal to 1. You should be knowing that is the condition for normalization. I hope that is clear. This is the condition for normalization. Clear? So what I'll do now, I will take the integration like this psi star psi d tau like that. Clear? Then I'll put its value. What would be psi star? You can say psi value is this, c1 phi 1 plus c2 phi 2. So when you will be taking that psi 1 phi 1 plus c2 phi 2, so just simply putting the value and taking star, and then you are putting the value of psi, which is c1 phi 1 plus c2 phi 2, and then d tau, volume element, and that should be equal to 1. So guys, without wasting time, I'll be telling you this condition becomes like this. Guys, can you see if I take this, if I open it, if I take the multiplication of this with this and this with this like that, and then this with this and this with this, so in overall what I'll get this condition. So guys, you can see that when I'll be multiplying it, I'll get this condition, and after that now I have got this one. Fine, I have got this one. So now integration of this, when I multiplied both brackets, so this was the relation which I was left with. Clear? So now what I'll do, I will take these constants outside, because these guys are probability, and probability is always constant. Clear? So this constant, I'll take these constants outside. It would be c1 star. Clear? Because c1 and c1 star are constant. So rest is phi 1 star phi and d tau. Plus here also I'll take the constant outside. So I took c1 star and c2. Clear? And this phi 1 star phi 2 d tau. And here also again I took the constant outside, which is c2 star and c1, and c2 star c1, and then phi 2 star phi 1 d tau. Clear? I'm sorry. Then plus again in this case also I'll take the constants outside, which is c2 star and c2, and phi 2 star phi 2 d tau is equal to 1. Clear? So now I'll see, guys, I told you that the orthonormal condition should be there. Orthonormal condition was there. Fine, because that was the condition for this superposition principle. Clear? For that I told you that this one phi 2 and phi 2 d tau should be 0. Orthonormal means this, and this phi 1 and phi 1, I'm so sorry, that should be 1. Clear? And this phi 1 and this phi 1, clear? Phi 1 and phi 1 d tau is equal to 1, but phi 1 and phi 2 d tau should be equal to 0. Clear? Guys, there can be star also. Star only comes when I terms comes. Like suppose if phi 1 is something like that, root 3i, then you write star. Otherwise, if root 3 is there, you can write phi 1 also or phi 1 star also. Clear? You know, you must be knowing about that, so don't worry about star. I'll be just clearing this doubt in your mind that what is the basic role of this star, but for now just let me complete this. Clear? So I'll be explaining it here in this condition that what is the importance of star. Clear? So just be with me. Clear? So this phi 1 star phi 1, you know that this same one I told you, that is normalized and the value should be 1. So 1 into C1 star, that would become C1 into C1 star, plus now you can see phi 1 star and phi 2 d tau, the integration, you know that with another one. Here you can see that phi 1 with phi 2, that should be 0, so that became 0. Clear? And here also this 2 with 1, again 1 2 or 2 1, so here it will become, so this whole term will become 0 and this whole term will again become 0. Clear? So here also only one thing left, that is C2 into C2 star, and these are phi 2 and phi 2. You know that phi 2 integration was 1. Clear? So it will become C2 into C2 star, and I wrote it equal to 1. Clear? So guys, we can say that psi is normalized only when this condition is there, that is C1 into C1 star plus C2 into C2 star is equal to 1. Clear? So guys, here I want to tell you very important thing which will be very beneficial for you. So let me explain this to you, that what is this very important condition. So without it you can be trapped in the exam. So listen to me carefully right now. So guys, what will happen? Listen, suppose if C1, suppose a wave function is given like this, that okay, this root 3i and this psi 1 plus or phi 1, take phi 1, and suppose plus root 5i and phi 2 is given. Clear? So always, if in, you can see that these are wave function, but you will be thinking that these are C1. Please tell me, these are C1, root 3i is C1, can you tell me? And this C2 is, I'm taking example, I'm telling you, suppose a thing is there, this I is outside, suppose it's fine, this I is outside. Clear? So I'm taking just suppose, I'm writing over here, suppose. Clear? So guys, then if I terms comes in coefficient, so you will always go by this formula. Listen to me carefully. Whenever this C1 and this C2 will come, you will always write this C1 into C1 star plus C2 into C2 star is equal to 1. Clear? So how you will write this C1, that means C1 into C1 star plus C2 into C2 star, that should be equal to 1. Clear? So that means this C1, so that C1 means root 3i. So this star meaning, guys, I want to tell you the meaning of star. If plus I is there, if star is there, and after applying star, so plus I becomes minus I. Suppose if it is earlier plus I, it will become minus I after star. If suppose plus I star is there, guys, I'm telling here, if plus I star is there, it will become minus I. If minus I star is there, it will become plus I. That is the meaning, only meaning of this star. So star means the conjugate. Clear? So conjugate only make difference on this star, always make difference on this star, otherwise everything becomes same. And I'll be telling you with another example that how like suppose if without I things come, then how you will do that. So just hold on for this one. So this C1 star will become what? This C1 star will become now this root, it was plus root 3i, so it will become minus root 3i. Clear? And then plus now C2 is there, C2 is root 5i, C2 is root 5i, and C2 star will become minus root 5i, and that will be equal to 1. Then only you will solve it, then only you will check whether this condition it is equal to 1 or not. Clear? Then only you will check whether it is coming equal to 1 or not. Suppose if it is not coming equal to 1, so what you will do, that suppose it should be equal to 1. Now you will calculate this root 3 into root 3i, it will become minus and 3i. Can you see? Minus 3i square, and here it is again minus 5i square. Clear? So when you will be calculating it, you know that minus I square is minus 1, and this again I square is minus 1. So you can see it is plus 3 plus 5, that will become 8. Fine. So now you can see it is not equal to 1. It is not equal to 1. So what you will do? You will think of this like whatever answer is coming, your answer is coming 8. Clear? So for normalizing it, so your earlier equation was this, that it is root 3i phi 1 plus root 5i, okay, something that happened here, root 5i and phi 2. I'm again writing over here, it is root 3i and phi 1 plus root 5i phi 2. Clear? So my answer is coming 8. Fine. For normalizing it, I'll do one thing, guys. I'll do one thing, that I will take its inverse. I will take the inverse of this 8. Fine. And then I'll take the under root. And then I'll multiply it with this whole equation. Simply whatever answer is coming, if it is 16, or if it is 100, if it is 200, if it is 1000, 2000, any answer is there. Fine, apart from 1. If it is coming 1, then you will not touch the equation. If it is 1, then you will not touch the equation. That is the prime, guys. You need to do it. That's what I was warning you, that any question is there in superposition principle, you are going to check that whether there this C1 star plus C2 into C2 star is equal to 1 or not. Any question of superposition principle, this is the condition. This is like, just set this thing in your mind, that you are going to check whether this C1 into C1 star plus C2 into C2 star is equal to 1 or not. If it is 1, then it is well and good, and then you can proceed further. Clear? But if it is not 1, so whatever number is there, suppose my number came 8, so I will take its inverse. I will take it, suppose my answer came 8, so I will take 1 by 8, right? So I will take 1 by 8, then I'll take the under root, then I'll multiply it, then only I'll proceed it. So my new equation, so I'll proceed by my new equation. So my new equation will become this root 1 by 8 into root 3i 5 1 plus this one again, root 5 by 8. When I'll multiply root 1 by 8 into root 5, that will become I and phi 2. This will become my new equation, and then only I'll proceed further to calculate this probability and all. I hope this thing is clear to you guys. So I hope so guys, just keep this thing in your mind, that you'll always check whether this C1 into C1 star plus C2 into C2 star is equal to 1 or not. If it is not equal to 1, you will take the inverse of that number, and then you will take the under root, and then you will multiply that with the equation, main equation. Clear, guys? Also, now I'm going to tell you, suppose if something like that is not there, if this is not there. Clear? Suppose this I is not there, then I'll be going to tell you that what will happen in that case. Clear? Suppose I have now this root 5 and phi 1 plus root 7 into phi 2. Suppose I have this number, now I'm not having I in it. Fine. So I can simply write it like this: C1 into C1 star plus C2 into C2 star is equal to 1. Clear? So now this star will not make any difference to it, because this root 5, even after this 5 star, it will be only 5 only. Fine. This C1 star will be C1 if it is not having I. Clear, guys? It is not having I term. I means iota, if you don't know that. Clear? So you will simply now you can take this equation like this: C1 square plus C2 square is equal to 1, because this C1 and this C1 are same only now. Because guys, in I term it was different, because plus was becoming minus and minus I was becoming plus, but here it is same only, so we can write C1 square plus C2 square is equal to 1. Clear, guys? So you have to do like that. If suppose I terms is not there, if I term is there, so you will do it like the earlier one I told you. Fine. So let's come down to this thing, probability. So guys, in exam sometime it gets asked in this question, it gets asked in the exam, that what is the probability corresponding to particular state. Suppose I have this wave function, and it is equal to C1 phi 1 plus C2 phi 2. Clear? So examiner will be asking that this is the superposition principle, and tell us that what is the probability of finding the particle, I'm writing over here, of finding the particle in phi 1. In phi 1. So you don't have to do it. First you will check the condition: C1 into C1 star plus C2 into C2 star is equal to 1 or not. Clear? If it is not equal to 1, I told you what you have to do it. Fine. So then you will say that P1, the probability of finding the particle in this phi 1 state, that would be P1. Just write that would be C1 square. The formula of finding the probability of finding the particle in phi 1, that would be C1 square. Suppose it was root 5. Suppose it was root 5. Fine. Suppose it was root 5. You will suppose this root 5 phi 1 and plus root 7 phi 2 is there. So you will tell that probability of finding the particle in this phi 1 state is root 5 square. Clear? And probability of finding the particle in phi 2 state will be root 7 square. Clear, guys? Root 7 square. But listen to me. Suppose if root 5 I phi 1, suppose this is the wave function, plus root 7 I phi 2 is there. Clear? Then you have to see it like that. Probability of finding the particle in one state, that would be C1 into C1 star. Clear? Now that would not be C1 square. You know, whenever I will come, you will not take C1 square. You will take C1 into C1 star. Clear? So let's take it. It will become root 5I. Clear? And then it will become minus root 5I. Clear, guys? Then you will do it like that. Then you will find the probability. I'm telling you just example. Clear? Suppose if it is asked what is the probability of finding the particle in phi 2 state, in this state, then you will be writing C2 into C2 star. That means root 7I, and this plus I will become minus I. This will become minus 7I, and that would be the answer. I hope that is clear to you guys. So that was easy only. The probability question come. So also, guys, one question also come from this superposition principle. So guys, I have told you that this one, the normalization thing, that take care of this C1 into C1 star for every question, whether it is asked for probability or average value. So I'm going to tell you that examiner will ask you from this principle the average value also. So let's see what will happen in the average value. Clear? So guys, in this exam, it can be asked that what can be the this one, average energy. Clear? For average energy, or two other things can be asked. So I'll be explaining you what can be asked in this topic. Clear? So let's see. Yeah, so let's see, guys, what will happen now. That suppose this can also be asked. So I told you this is the probability of finding the particle in another state, that in phi 2 state. Fine, this is the probability. That's what I explained in this one, in the last slide. Clear? So let's see, the examiner can also be asked that what is the average value. Average value. So guys, always take care that is average value of energy. This can be asked that what will be the average value or expectation value. Guys, these terms are same. Fine. So examiner can ask you the average value or expectation value. Average value of energy is there, you will always write E. Average value of energy is there, you will always write E. If average value of angular momentum is there, you should be knowing average value of average or expectation value. The meaning is same. Average value of this angular momentum is there, this L square. Clear? So you will always write it like this, L square. So guys, this L stands for angular momentum. If average value of LZ is there, so you will always write this, LZ. So guys, usually these three only ask, this LZ and L square. So I'll be telling you the formula also, what is the formula for this one and what is the formula for this one, and this will do according to what states are asked. Clear? So let's see what will happen. Suppose, guys, now I need to find the average value. I think I should explain you directly the formula, that what will be the formula for this average value. Clear? So I think this will take time to explain all this integration and all, and these are not that much of importance. So let me tell you directly this. Clear? So guys, this will happen. The average value you can find by this formula. This is the formula of finding the average value of energy. That is, I told you that average value you will write like this. You will write it like this. Clear? So you will be writing the probability. This is the formula. The P1 probability corresponding to phi 1 state, and then energy E phi 1, energy corresponding to phi 1 state, plus P2 probability corresponding to second state, and then energy corresponding to phi 2 state or second state. Fine. And this is the condition that phi 1 and phi 2 should be orthonormal. That means you need to check first that C1 star plus C2 into C2 star is equal to 1. Then you will go to this formula. Clear, guys? Suppose, fine, this can be asked. So any observable, suppose if it is asked that what is the value of average value of L square, then you will write probability of first state and L square value, then L square value for this phi 1 state. Clear? And then you will write P2 this is nothing. Find P2 and L square value for phi2 state. Clear? And similarly, it can be asked for LZ value also. That probability for first state and LZ value for phi1 state. Clear? For probability of second state and LZ value of another state. So guys, only anything can be asked. It will come here and here for individual state, and corresponding probabilities will come here. I hope that thing is clear to you. It is easy only. So guys, these things only ask, and like examiner only plays between these things, and I'll be showing you these questions where I'll be showing you that how examiner is playing with only these things, and how he is molding the questions, and how you can refrain yourself from this getting tricked, fine, from getting trapped into the trap of question. Clear? So let's tell me the summary of this video, what I have talked in this video, that this is the condition for superposition principle. Yeah, this is the condition. Clear? Where this C1 phi1 size C1 phi1 plus C2 phi2, where phi1 and phi2 are orthonormal. Fine. Orthonormal means C1 into this C1 star and this C2 into C2 star is equal to 1. That condition came for this. Otherwise, orthonormal thing I told you that this should be orthogonal also and normalized also, if you remember. Clear? The psi is normalized. That means C1 into C1 star plus C2 into C2 star should be equal to 1. That we read. Suppose if C1 and C2 are not having I, if C1 and C2 are not having I in them, in their values, fine, in their values, then you will write like this. You know that then you will write C1 square plus C2 square is equal to 1. And probability of finding the particle in one state, that is C1 into C1 star or C1 square if there is no item. Clear? And probability of finding the particle in second state, that is C2 into C2 star is equal to C2 square. And then observable value, any observable, that energy value, L square value or LZ value, that would be probability, the P1. Clear? The P1 and the observable value corresponding to first state, and then probability P2, and then observable corresponding to another state. Also guys, I want to tell you one more thing. The value of this L square is this one. You must be knowing that L into L plus 1 h cut square. Clear? L into L plus 1 h cut square. Only h cut square is there. Clear? And this LZ value is mh cut. Always remember that. This LZ value is mh cut. And energy for hydrogen atom. Energy for hydrogen atom, you should be knowing that is minus 13.6 Z square by N square electron volt. Clear? And in this one, in atomic unit, the energy of hydrogen atom, I'm writing over here. Where should I write? I'll write over here. So energy of hydrogen atom in atomic unit, that would be minus 0.5 Z square by N square atomic unit. That is atomic unit. This is in atomic unit and this is in electron volt. So examiner only asks question from these things. So guys, that's it for this video. So in the next video I'm going to talk about all the questions, so you can see also. I'm going to show you that you can see the June question is there, and TFR question is there, and this December question 2015 question is there, June 2018 question there. So a lot of questions are there. I have taken questions from this one also, the physics also. Later on when we'll go into these slides, so I'll be telling you that how we can attempt the questions, like the very advanced question also, fine, so that even if the examiner raises the level, you can easily attempt the question. Fine guys, so that's it for this video. I hope you like this video, and this topic is very important, so guys, don't skip this topic. You will be seeing many questions coming in the exam from this topic. Fine, from now onwards we are going to take very important topics, the tunneling and the variation principle, Huckel molecular orbital theorem, and this one, this MOTVBT, and the spin and all term symbols. So these importance are like, you can't afford to miss it. Like, these are the real treasure of this quantum mechanics. Fine, so don't miss this topic. So guys, also one more thing. So yeah, if you want to follow me on this Instagram, so here is the link. You can follow me on the Instagram also, and you can drop message sometimes if I don't I'm not so frequent in comment section, but you can also leave something if you have some query or something like that. You can leave a message on Instagram also. I'm very much active there, so that is the link. That should be somewhere here. Clear? And also guys, I'll see all of you in the next one. In the next video, I'm going to talk about this questions and all, right? So I hope you like this video, and that's it for this one. So bye and keep smiling. Bye bye.